Espresso Talks by Sphere Energy.
Hello everyone and welcome to episode 4 of our Espresso Talks. Today I'm super happy to be here with two of our data scientists, Victor and Liam. And I would say let's just kick it off with a little introduction round.
Maybe I can get started then. So my name is Victor. As Emmy said, I am a data scientist here at Sphere, and I am responsible for a host of different things in both the battery test center that we have here, as well as data-related client projects. So part of what I do is ensuring that the entire data infrastructure here at the test center is set up and running properly. On the other hand, I also use machine learning and other sort of more, let's say, some more traditional data engineering in order to build data processing pipelines for ourselves and for our customers or clients.
My name is Liam. I come from more of a test engineering background. So with that niche context of how battery data looks, how it's processed, how you analyze the results, I handle a lot of the development of the processing library that is involved with our battery analytics platform that I think we're going to touch on a little bit later, creating the processing pipelines for our internal use, doing some consulting works for improving the automation in battery processing pipelines for some of our external clients. And there's a few more details, but I think that covers the most of it.
Yeah, Victor, I mean, you mentioned our battery test center, and it's actually where we're sitting right now. Here we produce huge amounts of data, right? And battery test data specific. Can you tell us a little bit about what kind of data we have in here that we produce daily and maybe what some challenges are that come with that data?
You let's get started?
Yeah, sure. So, I mean, we have, I don't know, I think it's growing every month, but I think we have maybe 12 to 15 battery cyclers, each of them with 24 to 64 channels, each of those testing 24 to 64 cells, however they're paired. And those are running constantly 24 hours a day, running different types of tests, rate performance tests, cycle aging tests at all different sample rates, sometimes multiple points per second. So these files can grow quite large. And so I think we're producing maybe around 2 terabytes of data a week, and that's measuring the voltage, the current, pressure, temperature, any other metric that we need to analyze data. So this is for our internal use and all the clients that we test with externally.
And the big problem arises essentially when you want to start utilizing this data as a test engineer. So by default, these cyclers store their data locally. And like Liam already said, we have lots of different cyclers running, but these are not all cyclers from the same producer. So each of these cyclers, or many of these cyclers, record data using different methodologies, using different formats, using different, even just simple things such as column names are different for the various cyclers. So in order to make the data available to our test engineers, what we have to do, and in order to make them not only available for the test engineers, but also for lots of the processing pipelines that we have to harmonize all the data. So this is quite a complex process, but essentially we need to push the data that we have from the cyclers to the cloud. Then we have all this harmonization and cleaning pipeline that that runs on servers, again, cloud-based servers. And then once that is done, we have sort of harmonized raw data that can either then be further processed by our automated pipelines or further processed by our test engineers using in sort of a simplified manner.
And I think what's a critical point that you touched on, I think it's really undervalued in a lot of companies worldwide, is this generic form enables an infinite amount of possibilities, because for our use case, we have one massive subset of data and it has 20 different directions that it has to go in. Parts of it go for training our foundational model, parts of it go for benchmarking cells, parts of it go for this client, and 15 other parts go for 15 other clients who all have unique processing. And so by creating this standardized format, we cut 20 hours a week of manual labor down to just nothing but computer automation.
Yeah, I mean, I'm sure our audience, at least I am also very curious about a little bit more of the background, because some of our audience might not know how data comes off of a cycler. What kind of data is there? How does it look? And how do you go from that kind of, what you said, unstructured data to actually clean data that you can use, for example, for analysis or things that you mentioned?
So maybe I can elaborate a bit on what I touched upon earlier, but it's a very good question. Essentially, well, as I said, and as you mentioned again, there's all this data from all these different cyclers, and they by default store these things, store them locally. So what we have is first of all, scripts that run almost continuously in the background that push this sort of raw data, these databases, to the cloud. So we ourselves are in the AWS ecosystem, and so all these cycles are connected to our AWS ecosystem, and this data is pushed to the cloud. Then what happens is we also have servers running in the clouds, and these servers need to be very performant because, as Liam already mentioned earlier, we generate terabytes of data on a weekly basis. And so what this does, or what these servers do that run in the cloud, they take this raw data, they harmonize and process it. But I think what's important to note here is that the harmonization it doesn't just happen with the raw data. All these cyclers also generate metadata, which also is required for this processing. And what this harmonization script does is takes the data from both the metadata and the raw data from the different sources, combines them, and then re-pushes the data to another cloud database that we have, so that our test engineers can access it from anywhere, be it a test center or being at home in another country, anywhere you'd like. On this, actually, maybe another thing that I should mention is that is maybe talk a little bit more about the metadata. So what our test engineers do when they start a new test, and maybe Liam can talk a bit about this as well, is they need to input information regarding the test that is being run. So some metadata is being stored by the cycler itself, for example, the channel that it's being run on, temperature, things such as this. However, what's important in order for test engineers to post-process it is information such as, the sample ID, which physical cell was it, what's the cell type, even things such as the anode and cathode chemistries are all very important. And in order to let's say store this metadata, what we developed was essentially a website that contains a cell inventory that test engineers can use to input this metadata. Maybe Liam can talk a bit more about this.
And I mean, this metadata is just bits and pieces of information about the cell that are all the independent variables that dictate how a cell behaves. And I think as the battery industry grows and becomes more competitive, the more bits and pieces you have to evaluate what is causing the performance that you're seeing, the more leverage you have in your own development. And I think what's critical about not just having this available when you're looking at the process data, not seeing what caused what, but also having this historic documentation. Because, if you're working at a really large scale where you're testing thousands of cells every day, 2 months down the road, someone's going to go, hey, have we performed a cell with this electrolyte ratio with this cathode material? And if you lost track of this information, if these bits and pieces fell between the cracks, you're either not going to know the answer, assume the wrong answer, or have to redo all the labor and money that you spent finding out that answer in the first place. So I think that's what we've developed with this architect, or with this tool that Victor has mentioned.
And again, the fact that we have this means that we can combine the data from all these different sources, and we don't have metadata and raw data siloed. What you have is one unified data source, and if you're looking at the raw data, you can see, okay, what electrolyte was it? Or like Liam said, in the future, you want to find raw data for a specific cathode chemistry. You can easily find it and harmonize. You can easily find it like this, and have the raw data associated directly with it.
No, I think that's a crucial point, and we also heard it from one of our previous guests, Wolfgang, CTO of Festool as well, how hard it is also across from departments to share data and to also maybe explain data to a department that is not as technical. as you guys, for example, are. And you just mentioned it before, Liam, that you have this internally, this is cell inventory, this database that you share with your test engineers. Do you also do that for other teams, or how do you, let's say, share the data with, yes, less technical teams, for example?
Right. I mean, that's a great point, because it's one thing to have the data available. You know, a ton of companies make their own data, buy data from cell developers or external testing facilities like us. It's easy to own terabytes of data. It's wildly available. What's hard is making it actionable and making it accessible. And so that comes with A, the processing, and B, the visualization. And so, you know, the way Victor and I do it, we have a file and we run whatever code we write on it and visualize it in whatever completely customized way we want. Obviously, that's impractical to expect everyone in a company to access it in the same way. And so maybe this is a good segue into breaking down what we've developed internally as a tool, or that's at least how it started, and what we're now making available to our clients and anyone else that encounters the same issues we did. And that's our Halo, our battery analytics platform that basically facilitates everything we've said into one location. So it takes your raw data, it takes the metadata, it takes the process data, and it takes any visualizations you want and puts them in the same location. And I think maybe before we go into how we use it, we can give maybe a quick overview of the architecture of it. Of where, I mean, it's quite straightforward. I think you gave we work in the AWS ecosystem, and this is essentially a visual for that.
Yeah.
But maybe you can give some more detail.
Maybe what's important to mention here is that all the effort we do on the harmonization front is essentially a precursor and requirement to enable all the more powerful things that come after it. So these things are such, for example, this can be sort of AI end use cases in which we try and predict the end of life of a battery, or the use case of having a sort of harmonized data management and data visualization platform, which is this Halo that Liam had mentioned. As in terms of how this works, so essentially the Halo, like Liam said, is a front end that allows you to see all the metadata, the raw data, and the process data in one place in a very intuitive and easy to use interface.
Sorry for interrupting. This just sounds like a platform to enable you to visualize and interpret all this data.
Yes, so it's exactly what you said. It's a platform to allow you to visualize and analyze the data, and this is all enabled by the fact that we have the sort of harmonized raw data, metadata, and process data all in one place. So to talk a bit more about the architecture, maybe it connects directly with our data infrastructure that we have on AWS. However, we can also deploy this on the side of the client, and in that scenario, we deploy both the container that hosts the Halo on the side of the client, and it also connects directly to the cloud data space on client sides that we do not have access to any of that data. But this is essentially the sort of ingredients of this platform is not just the Halo container that runs the app, it's the harmonized cloud database that we were just talking about, and a KPI processing container, which takes all this harmonized raw data and generates insights that are actionable from this raw data and that test engineers and others are most interested in.
I mean, maybe for some of the people interested in this Halo, can you talk a little bit about what features Halo has? Like, what is it able to do? We said visualize and interpret data, but what does this mean?
I think one point that's quite relevant to what Victor just said is, you know, and what typically is most important when anyone is making any decision based on battery data is what the process values are. Obviously, you know, as anyone who has an experience with it, there's specific key metrics that dictate if a battery performed well for your use case, whether you're a power tool, a car manufacturer, or a stationary energy storage. And it's how you extract these is key to your pipeline. And for us, there's a lot of maybe open source platforms that you can use, CellPy, PyBam, or you can have a team of, a software team that creates bespoke scripts for every different value you need, DCIR, this or that. But the issue that you have, and it's one that we encountered when we started expanding our facility, is when you have, you know, in the case of an external test facility, a bunch of different clients or maybe a bunch of different projects, you start to need different parameters that are similar enough, but different enough where they need specific features or changes in how they're calculated or how they're measured. And so you can either have this redundant labor where you have to write the scripts again and create a new pipeline to access this data versus this data. And what we've enabled based on this harmonized metadata where all the information is available is a no-code processing library. And so, tools like PyBam or CellPy, a lot of them do the same thing, but they require a lot of labor or input from the user, whether you have to give the schedule or break down, where the DCIR pulse exists in a test, or where, the pseudo OCV curve happens. All of this you typically have to explicitly mention, but what we've developed is a processing library where all you have to do is say which test type you're trying to process, whether it's a RPT, a cycle aging test, a rate performance, or sorry, a current limit test, whatever. We have a predefined set of metrics that are relevant for this test type, and every feature for that is automatically detected regardless of the test type. Any person watching now could send us one of their test files, tell us what type of test it is, and we would spit out, if it's an RPT, this capacity check, the DCIR, the 2C C-rate discharge that they want. And so all of this is enabled with no-code blocks where you just select the metadata that's relevant. So I say for project X, all the cells with, say I want it for all the cells with this type of electrolyte, process all their RPTs like this. And from that point on, any tests that get uploaded matching that criteria get processed in this way. And any tests that have ever been uploaded historically can also get retroactively processed.
So that is definitely the most powerful feature of the platform. It's this data processing library, which connects directly into the sort of KPI processing container that comes along with it and automates this whole process from going from raw data to the useful KPIs or process data. Obviously, the other important features that are built that are required for such a platform are powerful filtering and powerful visualization. So what we have is we essentially have all the metadata in one place, like I said, and we have and not just automated metadata tagging, so essentially automated adding of metadata to certain tests, which enables lots of the different filter parameters along with what the test engineers input in this in the cell inventory, which we touched on briefly earlier. But what this enables is also, what the platform enables is also fast filtering. So based on all the metadata, you can choose any metadata parameter, quickly say, I want to have, this cathode chemistry, or I want to have this sample ID, this cell type, and then you can easily quickly find all the tests that you're looking for that cell type, for that sample ID. You can also filter based on the test start date and the test finish date to find the exact test you're looking for. That's all. That all enables sort of rapid finding of the test you're looking for. What you can then do is select one or multiple tests and plot them again very quickly and very efficiently. So you just select multiple test files. For example, you say you want to plot the process data, and you have beautiful plots and curves of the process parameters that you are interested in. Maybe one last thing that I quickly want to touch on briefly is, I know we've spoken about a lot of the features, but something that's very powerful as well is sort of AI-based anomaly detection. So as part of the harmonization pipeline, we also check to see if there's any anomalies either within a certain test or within multiple tests of the same cell type. And this data is added to the metadata, so you can also very easily and quickly see on the platform when a certain cell is behaving strangely, or if a certain cell did not complete properly, or if there were weird observances. Sorry about
this
going on, but
this was a great overview. I was laughing before because you made it sound like it was so easy to just send over data and work with it now. But all jokes aside, who do you think this platform could be useful for? I mean, I'm sure you already work with some clients, but who did you envision this for other than yourself?
I mean, it can be for a variety of reasons, right? It can either be you don't have the manpower to develop this internally, you don't have the domain expertise, or, I mean, you have valuable data, and it can either be a bottleneck to your progress, trying to manage it, trying to process it, trying to extract tools, right? It can either create latency from going from generation to team X, to the simulation team, to the management team making decisions. There can either be 2-3 days of lag time between each point of communication, or it can be an extremely efficient stream of decisions and whatever you need it to be. So this platform it just enables that for anyone that needs it.
And this is what you're experiencing yourself.
Absolutely. I mean, with the scale that we've grown in the time frame that we've grown, without this tool, it would have been, it's hard to put a scale on how much more labor it would have required, but a great deal.
So I think it really benefits anyone from test engineers to project managers and even, C-level executives.
Maybe one point, since we're talking about Sphere right now, what is lying ahead of you guys? Because you've talked about what you've developed so far. What do you see as either your next big step, or what are the challenges blocking you from going any further right now?
Well, I think we've obviously developed this in-house. We've expanded it to a number of clients, and we're continuously building it on their feedback, where they see the most use. Because the last thing we want to do is have something with a bunch of extraneous features that no one uses. So we're really sticking to what the backbone of it is, what the critical functionality of it is, and that's the feedback we're taking and constantly in development. And of course, we have a number of other tools at Sphere that we're eventually trying to work and connect, because that's our mantra, is connect all the information possible. So whether it's this inventory tool, or whether it's our Apex simulation tool, with all of that hopefully can be, in an ideal world, hosted on a single platform where you have access to everything you could want: predictions on capacity over cycle, historic views of comparisons across these cells, and anything you need to make informed decisions.
Yeah, and I think what's important to mention is that we are really at a tipping point here, in the sense that, data can become either a bottleneck or a key enabler for modern AI tools. I touched briefly upon AI tools earlier, but as I said, the huge benefit in our space, at least, is predicting the end of life of a battery, or predicting the performance of a battery at, for example, temperatures that weren't tested explicitly. And you can talk to anyone in the automotive industry or any other sort of power tool producer that, the testing of a battery and its performance is what takes an enormously long time, and what generates all this data. And so really reducing the amount of data required through AI tools is the end goal you have in mind. And as you said, what is important for this is the harmonization of data, the automated data quality checks, the automated processing to generate KPIs, and what Halo does is, as well as our sort of wider KPI processing and data harmonization scripts and ML models that we've developed, what they enable is exactly this sort of future. And so, Halo is the foundation of this. Halo is what enables this, and we truly believe that this is the future that we're striving towards in the battery industry.
Yeah, thank you so much, Victor, and thanks to you for tuning in. I think we heard a lot about what becomes possible when data flows seamlessly within an organization. And if you as well want to hear more about how to turn your data from a major headache into a massive asset, then reach out to us, and the guys will be more than happy to talk to you about that and give you some more insights. Otherwise, I'll see you in the next episode of Espresso Talks.